Now, let me outline task 2 and task 3. First, recap the active defense framework. First, we compute representations for incoming queries. Then we estimate the coverage of the representation space for each user. And based on this coverage, we compute the cost of queries, expressing it as noise added to representations. Now, some of you may already come up with an idea on how to breach this defense mechanism using multiple accounts. If you did, you are depicted here as a smart attacker. A smart attacker may use the so-called Sybil attack. First, they set up multiple accounts and send only limited number of queries from each account. Alternatively, they query only a single region of the representation space from each account. In this scenario, each account would receive representations with a negligible amount of noise from the API. The attacker could then gather those representations to train a stolen model. So, how do we prevent this from happening? To defend against Sybil attack, each user received representations transformed with a unique per-user transformation. Those transformations have the following properties. They maintain the utility of the representations for downstream tasks. They prevent using multiple Sybil accounts to train a stolen model by gathering representations from multiple accounts. And as I said, they are different for each user. Examples of such transformations are an affine transformation or padding and shuffling depicted at the left side of the slide. An even smarter, adaptive attacker can still try to execute a Sybil attack. To use representations from different accounts, transformed with different transformations, the attacker must find a way to map the representations for one account into the representation space of another account. For example, an attacker may try to train a mapping neural network. For this strategy to work, each account must share a common set of queries that will be used to train the mapper. Here, this set is depicted as B, and the queries unique for each account are depicted as A, C, D, and E. Your second task will be to try to breach this layer of defense. The goal is to reverse an unknown defensive transformation. The final evaluation score is higher when the submitted set of representations is more similar to the set of original representations. In the third task, you will try to devise your own defensive transformation. The goal is to create a new defensive transformation that maintains utility of the representation, and this in more detail means that there will be a threshold on how much accuracy decrease on a specific downstream task is allowed when your transformation is applied. And also, this transformation should prevent using multiple Sybil accounts to train a stolen model. The final evaluation score here is higher when adversarial mapping is less accurate. To finish, let me describe our end-to-end bugs for bucket solution. First, when a user sends a data point to the API, the encoder calculates the output representations. Then, we measure the coverage of the representation space for cumulative queries for a given user. We map this coverage to a particular cost using a predefined cost function. To prevent model stealing, we express this cost as noise added to the representation. Finally, to prevent Sybil attacks, we transform these representations before returning them to the user. This transformation is unique for each user API endpoint. Thank you very much for your attention and have fun solving those tasks at the hackathon.